Okay. So this Newton-Raphson method is another form of iteration. Okay. It is another numerical methods by which we can calculate the solution of any equation. Okay.
Okay.
So we'll directly go to that formula. Xn plus 1 equal to xn minus fxn divided by f dash xn. So first of all,
Okay.
you will be given that the function. Okay. You must have find first derivative of this function. Okay, just note it down. We'll do questions, then you will understand it how we are going to apply it.
Okay, so I'll just make a note of it.
Okay. Noted?
Yes, I just need to write the title and everything. I'll just
Just note it down.
So I just have a quick question. This formula they've done here from the top, there's like a graph. I think there was like an explanation as to how that happened. I don't get what that they were saying. F of
Okay,
x
okay.
equals x.
Okay. So the curve is given to you. Okay. Another fixed point iteration method, they start with an estimate of the root and improves on this called it is Newton-Raphson method. If you have an equation fx equal to 0, you will be given an equation like fx equal to 0 and you have an estimate x1 for the value of a root. Okay, so this estimation you have that x1. So then you can get a better approximation x2 for the root by drawing in the tangent to the curve at x1. So if you draw tangent at x1, so what will happen? So tangent to curve at x1 and working out where this crosses the x-axis, this is shown in figure 14.17. So this x1 is given to you. So at this x1 you are drawing a tangent and you see this one. Okay. This one is, if this is x1 and let us say this is the entire one is x1. Okay. And up to here it is x2. So how much it is? This is x1 minus x2. Okay.
Okay.
See, this whole one is x1. This entire one is x1. And
So x1 minus x2. Okay.
This one is x2. So this value will be x1 minus x2. Okay. And this will be fx1.
Why is it fx1, sir? Oh yes, yeah.
It is the value of y at x1. So that will be given as fx1. Got it?
Yes, I got it.
Okay. So using the right angle triangle, this is very simple. If you use right angle triangle, the gradient will be fx1 divided by x1 minus x2. Okay.
Okay.
That is the way to find gradient.
Yes, sir.
And gradient is always equal to the first derivative.
Yes, sir.
Okay, so that means, so fx1 by x1 minus x2, that will be equal to f dash x1 equal to fx1 divided by x1 minus x2. Got it? Now you take x1 minus x2 that side. So our motto was to find x2. So x2 is x1 minus fx1 divided by f dash x1. Okay. So repeating this process, if you repeat this process, that will give you x3. So how you are going to find x3? So x3 will be x2 minus fx2 divided by f dash x2. So if you go on, you will get it xn plus 1 equal to xn minus f of xn divided by f dash of x1. Okay. So this is called as Newton-Raphson method. Okay.
Yeah, okay, so I just didn't understand one thing.
Hmm.
Um, Above, sir, where the graph was drawn, it says if you have an equation, f of x equals 0.
Hmm.
But I don't get f of x equals 0 is just a straight line, like vertically, so
It is a
horizontally. So what are
function.
the.
It is a function, yeah. Straight line is just a tangent. This
Okay, but why
is
did they say f of x equals 0, sir?
this is the curve, yeah. This one, red one. Red one is the curve. Y equal to fx.
Yeah, so what about f of x equals 0?
F of x equal to 0 is a curve. Your curve will be given like this: x square minus 2x plus 2 equal to 0. What is this? This is f of x.
Oh, I thought they meant like y equals 0, just like a straight
Yeah,
line
y
vertically.
equal to 0 is also there. This is your curve. Fx equal to
Okay,
0. Okay. And this blue
okay,
one is the tangent. Tangent at this curve at point x1. Okay.
okay, okay, sir, got it.
So now we'll see how we are going to apply this method. So just try to do this method. Just try this example. Try this example by Newton-Raphson method.
Okay,
Okay, x1 value is given to you like x equal to 1. Your root is in between somewhere 1 and 2. Okay.
okay, yes, sir. F of,
You have some problems with Newton-Raphson method. If your initial value is close enough to the root, then the Newton-Raphson method will almost always give convergence to it. Okay, that means it will be always closer to that value. If you do more iterations, it will be getting closer, but it
okay,
so the rate of convergence to the root using this method depends on the choice of initial value. Okay, so
okay.
that is, I think it is not a problem, but they have written it a problem.
Hmm,
Okay.
hmm,
So you have to choose the closest value as you can choose. Okay.
okay,
So the rate of convergence to the root using the method depends on the choice of initial value and the shape of the curve in the neighborhood of the root. If the initial value is not close to the root, then the iteration may converge to another root or diverge. Okay,
okay,
in the following figure, the second approximation x2 is further from the root alpha than the initial approximation x1. Okay, we can see that. Yeah, this one. Okay, because where is your root? There are three roots: alpha, beta and gamma. Okay.
okay,
So if you choose x1, so that will be closer to beta. Okay,
okay,
because they are approximately they are at the same distance. So although the starting point x1 lies between the root alpha and beta, the iteration actually finds the third root, that is gamma.
okay,
Okay. So that is one problem, because what happens when x1 is at a stationary point? It may
hmm,
be a stationary point. Okay.
okay,
So at stationary point, what happens? Your f dash x becomes 0, isn't it?
yes, sir.
So that time your Newton-Raphson method fails, because your formula is xn plus 1 is equal to xn minus fx divided by f dash x. Okay.
Okay,
So at stationary point, f dash x will become 0.
okay,
So you can't take stationary point.
okay, okay, got it.
Got it?
Yes, sir.
So that thing also you have to keep in mind. So f dash x1 is too small usually because x1 is closer to a stationary point as shown in figure, although the starting point. Okay. Okay, the Newton-Raphson method may break down if the function is not defined over the whole range of R.
Okay.
that I told you, because its differentiation is not possible. Okay.
Okay.
Whatever the range it is not defined, in that range its differentiation will also not be defined.
Okay.
Okay, so that's why, because in Newton-Raphson method there is a term like differentiation. So if that differentiation is not defined, then your Newton-Raphson method may break down. Okay, so that means you have to avoid stationary points. Okay.
Okay.
Okay, is discontinuous. It may be a discontinuous function. Okay, just try this exercise 14.2.
Okay. So I have a question.
Yes.
Just above, so it says the Newton-Raphson method may break down if the function is not defined over the whole way to the same point, sir. So because the tangent may meet the x-axis at a point outside the domain. But so
See,
what if like
if your function is not defined in particular domain, then your differentiation will also not be defined. To use
okay.
Newton-Raphson method, your differentiation must be defined.
Okay, but so let's say, for example, the differentiation is defined. Um, let's say the first derivative is defined, sir. I think what they're saying is, even if the first derivative is defined, maybe it meets the x-axis at a point where it's the domain's not defined. So then that wouldn't make sense. I think I got it. Okay, that wouldn't
Yeah, your
be
domain
possible.
must be defined at that point where your x1 you are taking it. So that must be defined.
So can we say both things? Can we say can we say first derivative has to be defined and the domain has to be defined at where the tangent meets
See,
the x-axis?
if your function is not defined, then there is no need to find differentiation.
Okay.
Okay. If differentiation is not defined, then function may or may not be defined in that domain.
Okay.
Okay, that is not necessary. Sometimes if your differentiation is not defined, your function may be defined. Okay.
Okay.
But if your function is not defined, then definitely differentiation will not be defined in that particular domain.
Okay.
Okay. So if your function is not defined, then you need to check your differentiation. It will not be defined. Got it?
But if the function is defined, okay. But if the function is defined, sir, um,
There
since there's
may
a two.
there may or may not be your differentiation is defined.
Oh, okay, fine.
Okay, like you have a function. Uh, you have a function fx equal to okay, function is defined, fx is defined, but f dash x is not defined. Okay,
Okay.
that may happen. That may happen. Okay,
Okay.
got it? We'll do.
Okay, got it.
We'll cover it once we will study that calculus.
Okay. I just make a note of the problems with the Newton argument.
Okay. Just note it down.
Okay.
See, you can have an example like fx equal to log x plus 1. Okay.
Okay.
So what is f dash x? F dash x equal to 1 upon x plus 1. Okay, here your function is not defined at x equal to minus 1, and even differentiation is not defined at x equal to minus 1.
Okay.
So that is not satisfactory example. Fx is log x plus 1.